Okay. So extraneous solutions, we need to talk about those. Extraneous solutions are solutions that you will receive when you work out your problem, but they don't satisfy the original equation. So they don't work in the original equation. Sometimes you can figure out the extraneous solutions by just looking at where your radical is. So this is a square root, so that means I can't have a negative in here. So I can't have anything less than -2, right? Because -2 would give me a 0. If I had a -3, I'd get -1, and I'm not allowed to have negatives because we're just in the real number system. So if one of my solutions was, say, -4, I could just look at that and go, oh, that won't work. Other ones, we're going to have to actually plug them in to make sure they work or not. Okay, so the first thing we want to do is we need to get this by itself. So I'm going to subtract 4 from both sides. Okay, and now I have a square root, so I am going to square both sides. So I get x plus 2 equals 9. I'm going to subtract 2, and I'll get x equals 7. And now we had said that this can't be less than 2, -2, right? 7 is obviously not less than -2, but if you want to double check it, we just plug it in, and we have to make sure it works. So I have the square root of 9 plus 4 equals 7. This is true. Since that's true, this is true. Okay. Here where I have a radical on both sides, I can't isolate it completely. So when this happens, you have one radical on each side, and you square both sides completely. And what that will give me on this side is x minus 12. And on this side, I'm going to have some foiling to do. So 2 times 2 is 4. 2 times, that gives me -2 times the square root of x, minus 2 times the square root of x, plus x, right? So I'm going to have x minus 12 is equal to 4 minus 4 times the square root of x plus x. And now I need to get this radical alone. So I'm going to subtract x from both sides and subtract 4 from both sides. Which will give me -16 is equal to -4 times the square root of x. I will divide both sides by -4. And that gives me the square root of x is equal to 4. And then I have to square both sides again. Okay, so I want to just double check this and make sure it works. It should, but I just want to check it. So I have 16 minus 12, so that gives me the square root of 4, which is 2. And then I have 2 minus the square root of 16. So that's 2 minus 4, which is -2. Is that true? No. So this actually, I end up with 2 equals negative 2. That's not true. So this is not true. I shouldn't probably use x's for that. Okay, how about this? No. Therefore, no. If that happens, no solution. Here we have a cube root equation. So if I have a fractional exponent, that's the same thing as a root, right? We talked about that already in this chapter. So I'm going to get this alone. So in order to do that, I'm going to add 4 to both sides, which is going to give me 2 times the cube root of 6x minus 3 is equal to 4, which I will then divide by 2 from both sides. And so I'll get the cube root of 6x minus 3 is equal to 2. Now, because I have a 1/3, which is a cube root, I'm going to take both sides to the power of 3. So I'll get 6x minus 3 is equal to 8. Okay. Add 3 to both sides. 6x is equal to 11. Divide by 6. And x equals 11/6. Okay. And then we need to check it. So I'm going to plug 11/6 into the original equation. If I multiply 6 times 11/6, my 6's cancel. So I get 11 minus 3. So this is 2 times 11 minus 3 is 8 to the 1/3. The cube root of 8 is 2. So that's true. This is true. I'll go ahead and do the next one. Going to subtract 1 from both sides. And I get the cube root of 3n plus 2 is equal to negative 1. Now, if this was a square root and this was negative, I would already know there was no solution, right? If this was an even root and I got a negative number, that's not possible. But because it's an odd root, I can have a negative, so it's okay. I'm going to take it to the power of 3. So I get 3n plus 2 is equal to negative 1. Subtract 2 from both sides. 3n equals negative 3, so n is equal to negative 1. And then we want to check it. So I get negative 3 plus 2. Okay, so I get negative 1 plus 1 equals 0. That's true. So this is true. Okay, so fourth roots, I'm going to isolate this. So I'm going to add 6 to both sides. Divide both sides by 3. Okay, since it's the fourth root, I take everything to the power of 4. And I get 2n plus 6 is equal to 2 to the 4th, which is 16. Subtract 6. 2n equals 10. Divide by 2. N equals 5. And then we need to check it. Okay, so I've plugged in, I've done everything, it worked, so this is the correct solution. Yeah. Are you guys done? Yeah? Is that what you got? Awesome. Any questions on that one? Oh, I'm still recording. Why am I still recording? All right, next we have radical inequalities. Okay. We're going to take and solve this, but instead of being equal, it's less than or equal to. So, but it's the same basic process. I'm going to subtract 3 from both sides. And I get the square root of 5 minus 10 is less than or equal to 5. Square both sides. And you get, oh, there's an x. 5x minus 10 is less than or equal to 25. add 10 to both sides. Five x is less than or equal to 35. So x is less than or equal to 7. Okay. Once you've done that, one second. Okay. We've got that x is less than or equal to 7. But we had a radical in here, right? And that radical tells us that we can't have a negative number. So we have a second part to do. We have to take 5x minus 10, and it has to be greater than or equal to 0. So we're limiting our x's. So I'm going to add 10 to both sides, and I get 5x is greater than or equal to 10, so x has to be greater than or equal to 2, so that we don't end up with a negative under a radical. So that's 2, that's 7. X is less than 7, but it's greater than 2, so it would be between here. And we just want to double check it. In order to double check it, pick a number less than 2. If I plug a 0 in, I would get the square root of negative 10. That's not going to work, right? So it's not going to be less than that. And if I pick a number larger than 7, so let's say I'm going to pick 10, just because 10 is a nice easy number, I get 3 plus the square root of 40 is going to be less than 8. That's not true either. The square root of 40 is at least 2 times the square root of 10. It's going to be bigger. If you plug that into a calculator, it's going to be greater than 8, so it won't work. So let's try this next one. I'm going to solve the equation first. Square both sides. So 2x plus 2 is greater than 16. Subtract 2. 2x is greater than 14, so x is greater than 7. That gives us 1, but we also have this radical that can't be less than 0, so 2x plus 2 is greater than or equal to 0. Subtract 2 from both sides. 2x is greater than or equal to negative 2. Divide by 2. X has to be greater than or equal to negative 1. Okay, so if this is 0, greater than or equal to has a solid dot, and then I have greater than 7. So 1, 2, 3, 4, 5, 6, 7 would be an open dot. Now I know if I plug in anything less than negative 1, it's not going to work, right? Let me plug in something between here, because right now what I have is this situation. And I don't know if I can shade this part or if I only shade over here. So if I plug in a 0, because that's between the two, I would get the square root of 2 plus 1 is greater than 5. Well, the square root of 2 is like 1 point something. Plus 1 would be 2 point something. That's not greater than 5, is it? So this area can't be shaded. So I can only shade over this way.